Following on from the previous video, we've worked out that for a given volume, you should make the if you want to minimize the amount of material needed to produce this box, you would have to make the height to be this and the width here to be this. Okay, so this here is our solution for any given v here. Okay, but there's a more elegant way of expressing the answer. So let's start from the beginning again. So here volume is given by this. The amount of material needed is given by this. Okay, so we then buried this constraint within this area here. Okay, so we embedded our constraint into here. Okay, so that will then give us this. So now we've got the amount of material needed is given by this. So we would then differentiate it. That would then give us this, and then blah 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 blah. That would then give us this here. Okay, and all this was done in one of the earlier videos. So from here you can times both sides by x squared. That will then give you this. Okay, so here is our solution here. Hang on, let's start again. Bear with me. So we started out with our constraint here. We then buried this inside the y here. We would then differentiate it. That would then differentiate it. That would then give us this. Then we set the gradient to be 0. Okay. So here we've imposed the gradient to be 0 right here, meaning that at this stage here we are at the minimum now. We are at the minimum. So hang on, bear with me. We started out with a volume here. We then buried the constraint inside here, and then when we differentiate it and then set it to this here, we are now at a stage where we are at the minimum. Okay, we are now at the minimum. So when you look at this stage here, so blah blah blah, that will then take you to here. So when you get to this stage here, don't forget we've already buried our constraint inside here, and we've already reached our minimum, and all that is ingrained in here. Okay, so once you're at this stage here, remember originally the volume was given by this. Now we'll put this into here. That will then give you this. Okay, that will then give you this, and then divide both sides by 2. That will then give you, hang on. So when you're here, divide both sides by 2. That will then give you this. Divide both sides by x squared. That will then give you this. Okay, so when you look at this here, don't forget we've buried our constraint in here, and we've also reached our minimum in here. So when you get to this stage here, what it's saying is that to minimize the amount of material needed to produce your box, all you need to do is satisfy this. Okay, so what that means is, rather than expressing the answer as this and this here, all you need to do is say that to minimize the amount of material needed to produce your box, all you need to do is make the height half the size of the width here. So that's a much easier way of expressing the answer than saying this and saying this. So to minimize the amount of material, all you need to do is make y half the size of x. That's it. It's a much more elegant way of expressing the answer than this and this. Okay.